look at the last four. If they have a 0 in the numerator and denominator, that means we have that indeterminate form. Okay?
Does it mean that the limit does not exist? Or?
Well, it might, okay? But that's where we need to do a little bit of extra work to try it out and see if we can't get it into a form that's not one of those indeterminate forms. All right? Now, we talked about rationalizing when you had a radical or trying to factor somehow if you didn't have a radical. One of the things that you could have done in this case, though, it didn't fall exactly into one of those cases, but one of the things that we did was multiply by a conjugate. Okay? So if I have 1 over x plus 1, I can multiply that by that plus 1. Okay? So I'm using the conjugate of my numerator. All right? And this is just, you see it something like this, you just try it and see what happens. Okay? So for example, in this case, when we FOIL the numerator, we get 1 over x plus 1 squared, okay, and then that's going to be minus 1, over, we have x times 1 over x plus 1 plus 1, okay? Well, let's just see what we can do with this, see if that helps us at all, okay? And remember, the way that can help us is to try to get something that will cancel out the thing that is making a 0 in your denominator. Alright? Well, if I simplified this up here, okay, I would need to make this into a common denominator, x plus 1 squared, by multiplying by x plus 1 squared over x plus 1 squared. And in my numerator, I'm actually going to FOIL this. So it's x squared plus 2x plus 1. Alright, does everyone see what I did there?
1 minus.
I had a minus 1 here, so I just multiplied it by x plus 1 squared over x plus 1 squared.
Why does it get rid of the minus 1?
It doesn't get rid of the minus 1. I'm just rewriting it. This equals minus 1.
Oh.
Okay, I'm doing this though so that I have a common denominator in my numerator. Alright, and that ends up giving me, I have a 1 minus 1, so that's 0, but I have a minus x squared minus 2x over x plus 1 squared. Okay? I'm going to do, but that's my numerator only. Now I need to work with my denominator. Okay? So what I'm going to do with my denominator is, I'm going to do the same thing. I'm going to get a common denominator by changing that 1 here into an x plus 1 over x plus 1. Alright? So that's going to give me, I still have this x, alright, and I'll just put it in the numerator rather than having it outside parentheses, but I have an x plus 2 in the parentheses, and then that's over an x plus 1.
Can you explain how you got to the previous step?
Oh, I got to this?
No, how did you get the numerator in this step? In the second step? No.
How did I get this?
No.
How
Yeah.
did I get this?
Yes.
When you multiply, when you FOIL, you get a minus 1, right?
Yes.
Instead of using the minus 1, I chose to get a common denominator, x plus 1 squared.
Oh, okay.
Alright, and I just FOILed the numerator
Okay.
instead of leaving it factored out.
Okay.
Okay. Now, I have a fraction divided by a fraction, so what can I do?
Multiply.
How?
The word.
Flip it.
Yeah, flip it and multiply. Okay? So, guys, you see how some of the stuff we learned, well, you learned this probably back in Algebra 1 and Algebra 2, alright? Stuff like that is now becoming more and more important, okay? We have this complex fraction, we've got to handle it by flipping and multiplying. So I have a negative x squared minus 2x over x plus 1 squared, now times, if I flip that, I have an x plus 1 in the numerator, and I have an x times x plus 2 in the denominator. Okay? Now watch this. What I'm going to do is I'm going to take this numerator over here, and I'm going to factor. How could I factor that numerator? What could I take out?
Yeah.
Yeah, and you know what, I'm actually going to take out the negative with it. So a negative x, and then what's left is an x, okay? No.
My calculator.
An x and a plus 2. You awake now? And now look at what we can do. We can cancel some stuff out. Alright? So I can cancel out the x with the x, and I can cancel out the x plus 1 with the x plus 1, and I can cancel out the x plus 2 with the x plus 2 as well. So this whole thing simplifies down to what?
Well,
Yeah, negative 1 over x plus 1. Now don't forget what we're doing here. The whole point was so that we could take the limit, whoop, there it is, the limit as x approaches 0. Okay? Do we get an indeterminate form now when we find the limit as x approaches 0?
no.
No.
No. So now we can use direct substitution. Negative 1 over 1 is negative 1, and there's our answer. Okay? So you see here the limit part of it is very simple. It's all the algebra to get out of that indeterminate form that can be a pain. Okay? So,
On the quiz, are we allowed to use calculators?
um,
When is the quiz?
so,
Free day.
Friday. So.
Are we?
It's not going to be very long. We're going to do the quiz, and then after the quiz, we're going to start talking about the exam. So,
But are we allowed
Actually,
to use calculators?
we'll start prepping for the exam by working on some of your last test corrections and stuff. So, by the way, one other thing that you can do, if you see something like this, it may have been a little bit more efficient. I don't know. But let me erase some of this so you can see. When you have a complex fraction like this, one way of getting rid of the complex fraction is to look at this denominator and actually multiply everything. Actually, I think this would be quite a bit more efficient, but I'm multiplying by a form of 1, x plus 1 over x plus 1. That will cancel out this denominator, leaving me with 1 minus 1 times x plus 1 in my numerator, okay, over
X squared plus 1x.
x times x plus 1, yeah, okay. So now I have 1 minus x minus 1, so hey, yeah, this is a whole lot more efficient. So that's a negative x over x times x plus 1, and check that out, we get to the negative 1 over x plus 1
And like seconds.
God.
a whole lot faster.
Wait, what?
So you just multiply by the denominator, right?
You take, when you have this complex number, you can multiply by a form of 1. Notice I'm not just throwing something in there and changing the problem. I'm multiplying by 1, x plus 1 over x plus 1, and I have to distribute this x plus 1 to both parts, this and the minus 1. Okay? Yes, Jack? Yeah, that would work as well. Yeah, that works too. Alright, now, yeah, it is a lot easier. Okay, but you get there. We just walked all the way around the block to get next door, you know. So, alright, so let's take that same concept actually and apply it to these next ones. They gave you 21 intentionally because you're going to use a similar kind of concept to do the next 3. Okay? This takes us back to our trig. We're getting the limit as x approaches 0 of secant over tangent. Now, what's secant?
The inverse of cosine.
But it's the reciprocal of 1 over cosine. Okay, it's a reciprocal of cosine, so it's 1 over cosine. Then we're dividing by tangent. Okay?
Sine over cosine.
Tangent, sine over cosine. Alright? So if we're dividing by tangent, which is sine over cosine, that's the same thing as multiplying by, yeah, cotangent, which is cosine over sine. See how we flip and multiply? Okay? So now our cosines cancel out. Alright? And we want the limit as x approaches 0 of 1 over sine of x. Okay? Now, as x approaches 0, sine is approaching 0, right? Okay. Well, it means there's going to be an asymptote here. There is going to be an asymptote here. So in this case, our limit
Yes, the limit
does not exist, okay? There's no way to rationalize this. There's no way to simplify this, okay? So, does not exist, okay?
For all of
Questions?
the trig functions, do they not exist?
No. No. There are ones that do exist. I mean, the limit, if this were just sine instead of 1 over sine, it would equal 0. Okay. Alright, let's talk about cosine of 2x. Alright, cosine of 2x over cotangent of 2x. Alright, we have cosine of 2x divided by, what is cotangent?
Cosine over sine.
Cosine over sine, so it's cosine of 2x over sine of 2x. I flip and multiply, okay? So that's going to be now, times sine of 2x over cosine of 2x. That cancels.
And it gives you minus.
Now look, is sine continuous around x equals 0?
Yes.
Yes. So I can use direct substitution. What's the sine of 0?
0.
0. Okay? So here's one where,
Zero, but zero.
and notice in this case it's not 1 over sine, it's just sine, so it does actually, it will approach 0.
So every time you have 1 over something, it wouldn't exist?
I'm not going to say every time, but, well, and in fact, like if it were cosine, cosine of 0 is 1, so 1 over cosine approaching 0 would be okay. because it would just equal 1. So yeah, it's not necessarily every time you see 1 over something, but. Alright, what's sine of pi over 2?
Sine of 1.
It's 1.
1.
Is this our indeterminate form?
No.
No. This is a direct substitution one. Okay?
Mm. So it's indeterminate form when you divide the top by subtraction, right? Or
When the
not?
bottom's 0.
It's an indeterminate form when you get 0 over 0.
Oh,
Okay? Or if you get something over, it's really when you get something over 0. Like here, cosine of 0 is 1, but cotangent of 0,
Got it.
you know, that's going to give you an indeterminate form. Tangent of 0. Sine over cosine equals 0. Here, cotangent of 0 is undefined. Alright, so those are indeterminate forms. Here, though, you just plug it in and figure out what it is, and it comes out to the limit approaching 0. Okay? Alright. I think that's it. Any other questions about the homework?
No.
Yes, Jack.
13.
13? Okay. Alright, 13. First thing I would try is, what do you think?
Plug in.
Plug it in. Okay, let's see if it works. Just plugging it in. -1 cubed is
-1.
-1. 2 times -1 squared is
2.
2.
You get 0 over 0.
Plus 1.
1.
Plus 1 minus 2. So that's 0. So this is either an indeterminate form or it's equal to 0. So then I get a -1 plus 4 plus 1 minus 4. That's 0. So I'm going to have to do something with this one.
Mm-hmm.
Okay? Now, this is where try factoring by grouping first. Okay? In my numerator, I'm going to group the first 2 terms, and I'm going to take an x squared out of it. Okay? And I'm going to group my last 2 terms, and notice I had an x plus 2 in the parentheses, so I want to try to get an x plus 2 from this grouping,
So you took a minus out.
so I take out a minus 1. Alright? So my numerator here is x squared minus 1 times x plus 2. Okay? I do the same thing with the denominator. I'm going to take out an x squared, and in the parentheses I'm left with
X.
x plus 4. Good. So in order to get an x plus 4 here, what do I have to do with my second
-1.
grouping? Good. Take a -1 out.
X
So-
squared
How
minus
did you get
1.
the x squared minus 1?
Hang
Is
on.
your group.
Because this is a common factor
Right.
that I'm pulling out, and my leftovers are x squared and minus 1.
Oh.
Just like here,
X.
x plus 4 is a common factor. I'm going to pull those out,
And then x squared minus 1.
and I've got an x squared and a minus 1. Now, those are gone, so really I can just take the limit
And plug it in.
as x approaches -1 of x plus 2 over x plus 4, and that is continuous there, so it's, or around -1 it's continuous, so I can use direct substitution. Okay? So I get 1 over 3.
How do you know that one was confusing?
Well,
It's
where's
not
my
zero.
asymptote gonna be?
It's not 0, so there's no
Yeah,
answer.
there's negative
There's an
4.
asymptote here at
Negative 4.
-4, okay? So since I'm approaching -1, not -4, I know I'm gonna be continuous around there. There's evidently a hole here at 1 and -1. There are two holes in this function at 1 and -1. And there's an asymptote at -4. Yeah.
How do we choose what method we want to do so we can find the limit? Like, because for the first one, we did the very long one and then the short one, and for this, we use factor by grouping.
Just the experience. You can't really. There is no method to choose.
Okay.
Yeah. Well, and like here, we're dealing with polynomials.
Uh-huh.
Down here, if you're dealing with radicals, the first thing you'll try, again, by experience, as you get the hang of it, you're going to try rationalizing first.
Mm-hmm.
Okay? When you've got polynomials, look to factor first. Okay? Alright. Any other questions? Comments? Anything?
Could we do 17?
17?
Yes. It seems.
You're going to rationalize this?
Uh-huh.
Okay? This one actually wraps up pretty fast. What are we going to multiply by to rationalize?
Square. We're gonna square it. No?
Well, you can't just square it.
Oh, you can?
You have to multiply by the conjugate, right?
Oh, I forgot about that.
Okay, square root of 5 plus y plus square root of 5. And notice my numerator is going to end up being 5 plus y, because the square root squares. It's a conjugate, so the outers and inners cancel out, and then it's a minus 5. Okay? So look, the 5 minus 5 is 0. And I'm left with just a y in my numerator. The denominator is going to be y times that. And look, now my y's cancel out. And I have 1 over this, which when I plug a 0 in, I can directly substitute and get my result. Okay? Alright. So, just so you guys know, the answer then, if I plug a 5, or if I plug a 0 in, I'm going to get 1 over
Root 5.
2 root
Yeah,
5s,
2 root 5.
okay, or root 5 over 10. You rationalize it there. Okay. Alright, I know that's a little messy, but limits can get a little messy. So, I'm going to stop this and do a separate recording for the actual lesson.